Hi, I'm Gerhard Weber, anthropologist at the University of Vienna. I want to introduce some new findings that we made with regard to the famous Venus von Willendorf. This work is an excellent example also of how fields of anthropology, archaeology, and geology fuse into an interdisciplinary network, similar like in our new research network Human Evolution and Archaeological Science HEAS. We published our results in February 2022 in Scientific Reports. We applied new digital methods to the only 11 centimeter high figurine from Willendorf, which is one of the most important examples of early art in Europe. Willendorf is located on the left bank of the Danube in Lower Austria, as you see it here on this map, where also some other Gravatian sites can be found, like Krems-Wachtberg or Krems-Hundsteig. The figurine was discovered by Johann Veron on the 7th of August 1908, so more than 100 years ago, and the image that you see below is a snapshot taken on site that day with one of the excavation directors, Joseph Bayer. The plan of the excavation area shows the spot where the Venus was found. In later studies, several layers were redated using carbon-14 method. The Venus most likely comes from layer 8 or 8A, which has a calibrated age or range of 30,000.8 years to 29,000.2 years before present. Although found more than 100 years ago, the precious figurine could never be examined from inside. In our Vienna Microcity lab at the University of Vienna, we could perform the first high-resolution scans of the Venus. To stabilize the figurine during the 2-hour scan, it was placed in this styrofoam container. Already during the scanning, it became clear that the material was quite heterogeneous, showing light and dark layers and several dense inclusions. The immediate idea was that these properties could probably be used to identify the origin of the material, which did not come from Willendorf. Archaeologists were always puzzled about the numerous semi-spherical cavities, as you see them here, for instance, on the surface of the right haunch and leg. Also, the navel of the figurine seemed to have the same dimensions as these cavities, but was made obviously into a. The 6 dense inclusions in the body of the Venus could be identified as iron oxide congregations or limonites. Their diameter on average was identical to the diameter of the surface cavities. These hard limonites broke out when the creator of the Venus was carving it. In the case of the navel, he then apparently made it a virtue out of necessity. The high scan resolution allowed our geologists and paleontologists Matthias Hatzhauser and Alexander Lukeneder to identify a 2.5 millimeter large shell fragment that was included on the right side of the Venus head. The time when the stone formed could be dated to the Jurassic period based on this identification of the mollusk. So all later potential deposits from the Miocene geological era, for instance in the Vienna Basin, could be ruled out already as origin. The material of the Venus is known as oolite, a peculiar type of limestones consisting of thousands and millions of small grains called ooids. This is unique for Venus statuettes, which are usually made of ivory, bones, or other rock. Oolite is completely absent in and around Willendorf. The size of the ooids were measured using the micro-CT scans of the Venus and thin sections of rock samples from other localities, as those here from Stranska Skala, for instance. Our samples spanned a large distance across Europe, from France to the eastern Ukraine, from Germany to southern Italy. That is how the micro-CT slices and thin sections look like. In the statistics, we got one perfect match in northern Italy, one remote match in the Ukraine, and all other samples were much more distant and unlikely to represent potential localities for the origin of the Venus material. The distribution of the grain sizes were compared using a statistical method that provides a measure for similarity. The 6 samples from the Venus head and leg came out as indistinguishable from a location in northern Italy near Lake Garda. Less likely, but second, were samples from the eastern Ukraine. Here is a map of the oolite sites that were sampled from France, Switzerland, Germany, Italy, Austria, Bosnia-Herzegovina, Czech Republic, Poland, Romania, Crimea, and Ukraine. But the obvious did not happen. No site within a radius of 200 km from Willendorf came close to the Venus oolite, but Sega di Alla in northern Italy delivered this perfect match. The area around Sega di Alla is full of oolite deposits. This site our sample was obtained from is located on one of the hills above the edge value that you see here on this picture in the district of Trentino and near other Paleolithic sites. The isium finding is interesting insofar as some figurines in the vicinity in southern Russia have been found. They are younger than our Venus but similar in style. It is remarkable that there is obviously a connection between Trentino south of the Alps and the Wachau north of the Alps, and this about 30,000 years ago. In simulations, a hypothetical pathway here in yellow, in that time bypassing the Alps and moving into the Pannonian Plain was described. But potentially we think there could also be a route through the Alps, and that should be considered in further studies. That's the blue path here. Looking at the altitude, this 730-kilometer long path through the Alps along the Edge, the Inn, and the Danube, so following always large rivers, had always been below 1000 meters above sea level, with the exception of just 35 kilometers at Lake Reschen, where it reaches about 1500 meters. More systematic research in the Alps is needed to evaluate if this route would have been possible in that time. So to sum up, with the help of the 11.5 micrometer CT scans, the internal structure of the Venus from Willendorf could be investigated. The oolite limestone shows layers with different densities and laminate inclusions, which correspond in size to the hemispherical cavities on the surface of the figurine. The Venus oolite is porous, which is a great explanation for why the sculpture chose this material 30,000 years ago. It is much easier to work with. And by identifying one of the embedded shell fragments, we could date the oolite into the Mesozoic. Oolithic samples from near Lake Garda are identical in grain size distribution with the Venus oolite. A less likely origin would be the eastern Ukraine. No site within a 200-kilometer radius from Willendorf would even remotely match. People from south of the Alps were moving to the Danube 30,000 years ago. If they bypassed the Alps or crossed it, remains open. In any case, these results suggest a considerable mobility of these Kravatian people in the time around 30,000 years ago. Thanks to all colleagues who helped to make this study possible, to the Natural History Museum in Vienna for allowing access, and to the government of Lower Austria, who helped us greatly with financial support. If you want to see the original, please visit the Natural History Museum. Thanks for listening. Bye.